Hi all, this is part 3 of factoring using special products. Let's take a look. These are going to get harder. Let's take a look at x plus 1 quantity squared minus 9. Now there are a couple ways of doing this. You can multiply out your x plus 1 quantity squared and then collect like terms and see how it factors then. I'm not going to do that, okay? That's just, no. I'm going to treat this as a difference of squares because that's what I've got. I've got a squared minus b squared here. Write that out. I've got a squared minus b squared, right? That's a times b, excuse me, a plus ba minus b. In this case, my a squared, or my a, is x plus 1, and my b is 3, right? The square root of 9. So what we're looking at here, a plus b, x plus 1 plus 3, and then a minus b, or x plus 1 minus 3. Combine like terms, x plus 4, x minus 2. Done. Again, you can multiply out your x plus 1 times x plus 1 and collect like terms and factor that way. I don't think that it's the faster way to go, though. Alright, this next one in blue. 4 terms, right? Factories in the palm of your hand. Greatest common factor first. I don't have one. It's not a binomial. It's not a trinomial. But there are 4 terms. So you would think you could do this by grouping. You can, but don't group this the way you normally would, okay? I mean, you can try grouping your first 2 and then group the last 2. But it's going to drive you nuts. So, oh, by the way, I should have paused this and give you guys a chance to work these all out. So if you want to hit pause now and work these all out and see if you can get it, go right ahead. I am going to keep on going, though. So I'm going to group the first 3 terms together, okay? The reason I'm going after the first 3 terms is that's a perfect square trinomial. By the way, this is going to have grouping in it, it's going to have a perfect square trinomial in it, and it's going to have a difference of squares in it. Watch. Perfect square trinomial coming up. That's going to be x plus 1 quantity squared, and then minus y squared. Oh, this looks a lot like this guy that I just did, huh? So, it's the whole a plus b, a minus b thing. So I'm going to have here x plus 1 plus 1, and then x plus 1 minus 1. Done. Wow. In fact, your form looks worse than the original, huh? Alright, so that was there. Let's take a look at the next one. X cubed plus 24. 2 terms, right? So greatest common factor, not there. So it's a binomial. So it's not the difference of squares, but it is the sum of cubes. Alright, I'm using this formula right here. So my sum of cubes, my a is going to be the cubed root of x, which is, excuse me, cube root of x cubed, which is just x. And my b is going to be the cube root of 64, which is not 8. That's a square root of 64. I want the cube root of 64. That's 4. All right, so my formula, a plus b, or x plus 4. Trinomial, a squared, so x squared, minus ab, so minus 4x is how I'll write it. Because usually want the coefficient in front of the variable, right? So I don't want to write x4, that's weird. And then plus b squared, or 4 squared, which is 16. That guy's done. I get this question asked a lot. Can I factor that trinomial that comes out of the sum or difference of cubes? So I've been at this a long time, right, since the early 90s, teaching this stuff. And in all that time, I've only seen a couple instances where that trinomial that pops out of the sum or difference of cubes will factor. And it'd be something like x to the 6th minus y to the 6th, or something like that. And I'm not going to show that to you. If you want, email me and I'll show you at a different time. But if you're not one of my students, then ask around. I'm sure you can Google it or something. But almost all the time, that trinomial is not going to factor. All right, I digress. Let's do some more of this, all right? How's my time on this video? I'm going to hit pause right now, or close this video out, and we'll do a part 4 to take on these last 3.